Welcome to this video on load calculation for duplex. We're going to be using the standard method here, and we're going to be figuring out the minimum overcurrent protection device. I'm first going to show you how to fill out your page when you're filling out this load calculation, and that will also serve as a summary of the rules that I'm going to be going over in this video. After I go over that, you're going to know how to fill out your page to answer the question, and then I'm going to go over a question and I'm going to answer and fill out everything with you. This video is only going to be on the standard method. I'm going to have a separate video on the optional method for duplex, and then I'm going to have a standard and optional method also for multifamily. And they will each be in their own videos, and they will be in the same style to where you'll see the summary and the rules in the beginning, and then a question with me filling out and answering that question. These will serve as really good videos for you to come back to if you have any questions or you need a refresh on anything, because you're going to see that summary in the beginning of the video, and you're just going to be able to look at that and have a refreshment of all the different rules. Of course, you could screenshot it yourself, but this way, somewhere down the road, months from now, maybe years from now, you can think, oh, there's this Jared V Electric guy who has that video on load calculation for duplex using the standard method. And you can just come back to this video, and it's an organized way of being able to find this information, because all you got to do is find the video. Okay, before I get into it, I want to comment on the fact that I have this in parentheses times 2. That's going to signify the fact that we have 2 units here. So we're going to be getting what we have in our calculations and multiplying it by 2. And I'm going to walk you through it so you're going to know how and when to do it. And this in parentheses times 2 is going to serve as something that's very important for the duplex as well as the multifamily. Where in the multifamily, if we have, let's say, 15 units, then of course we're going to have in parentheses times 15. The reason why I put it in parentheses and do times 2 is because there are certain circumstances where you're going to, for example, have 2 air conditioning units and then 1 heater unit. Okay, so if you have 2 air conditioning units, and that is per building, and then you have duplex, you're going to be timesing by 2 for the building, and then timesing by 2 because you're working with duplex. So I'm going to show you my method, which is only having the times 2 in parentheses when it's signifying that we're dealing with 2 units. And this way you can go back to each separate section of the load calculation, and you can see that times 2 and make sure that you multiplied by the amount of units that you have. And then also, if let's say you had 2 air conditioning units, then you can compare your question and you can compare that section of the load calculation. I'm going to section everything, and you'll be able to see, okay, you multiplied by 2 units, and then you also did the in parenthesis times 2 dwelling units, actual buildings. Okay, so let's get into it. We're trying to find the minimum overcurrent protection device. We have a duplex unit, and we're using the standard method. Here's the rules, and then there's going to be an example after this. Of course, we're going to get the square footage of the house, and we're going to get that and times it by 3 volt amps. In other words, we're going to have 3 volt amps per square foot, which is according to the codebook's rules. From here, we're going to get a certain number. I'm just going to call N. And then at all times, unless we have an exception, we're going to be adding 4,500 to that number. Okay, if you've seen other methods, you might see people adding times 2, all these different steps along the way. I just like to add my times 2 one time, so I'm going to try to make it as simple as possible. And it's redundant, I say this in every video, but it's really good just to know that your 4,500 comes from your 2 small appliance branch circuits and 1 laundry circuit. They're all rated at 1500 volt amps, and this is why you have your 4,500 number. Check out my residential load calculation video part 3, where I explain an exception that allows you to leave out your laundry circuit if that is in the question. Okay, so we have our square footage of the house. We're timesing it by 3 volt amps. We get that number. We're adding 4,500. Okay, it's just like what we do always for the standard method, but we have duplex. Okay, so from here, we're going to get our total number, and we're going to multiply that by 2. That is going to give us an actual number, of course, but then from there, we're going to have to apply our demand factors. Okay, so from that multiplied by 2 number, we have those demand factors in the general lighting load portion, and I'm going to explain those demand factors when I get into the actual problem. I've explained it a lot in depth in the other videos, so I'm just going to briefly go over it. If you don't understand the demand factors of the general lighting load portion, it's a little complicated. Just check out my residential load calculation video. I'm going to link all those videos in the description, so just check out the description and you'll see the videos that I'm talking about. After this, I like to distinctly separate every single section, so I draw a line that's very visible. That tells me, okay, this is this section. I also label the section that it is. I'm going to label this general lighting load as GLL, and then I'm going to circle it just so I can see it quickly in the section that it is. But it's good to know that you'll see when I get into the calculation, I'm going to show the total calculation for this section with GLL all labeled in a circle, so I can quickly glance at it and see this is the general lighting load section, and then the total number that corresponds with that section, that all that I have to do from that total number is add everything together. Okay, so we're going to see that when I get into the question. After having the general lighting load portion, we're going to get into appliances. If you're familiar with how to deal with appliances in the standard method of load calculation already, then you're already going to know how to do this. But what you need to realize is that however many appliances you have are all going to be multiplied by 2. So if you have 3 appliances, we're going to be multiplying everything by 2 times 2. We're going to end up with 6 appliances. Okay, and that's why you really need to keep that in mind with the rule of Article 220.53, which tells us 4 or more appliances are rated at 75%. This is when they are rated at 500 watts nameplate or quarter horsepower or greater. Okay, so you might have 3 appliances, and right off the bat you think there's not that demand factor, but like I just said, when you multiply that by 2, now you have 6 appliances, you have to do that 75% demand factor. That's if they are rated at 500 watts or a quarter horsepower or greater. So this brings us into the idea of what if they are less than 500 watts or a quarter horsepower. Okay, don't overcomplicate it, just realize that you don't have demand factors if it's less than 500 watts or a quarter horsepower. So I'll make it 2 separate bulletin points. You see the 4 or more is at 75%, and now you also see that if you have appliances that are less than 500 watts or a quarter horsepower, you're not applying that demand factor. This is good to know because you might have some appliances that are 450 watts or a 6th horsepower, for example. When you add these in the appliance section, you're just going to rate them at 100%. There's no demand factor for that. Just like before, I'm going to actually circle that section to label it and have a line that separates its own area, its own section. But just like before on an actual question, I'm going to have the actual demanded load for this section circled with appliances. So I'm just going to look quickly at it and I'm going to see the number that I'm going to add at the very end to get that total demanded load. Okay, after appliances, I put this part in one section, but it's really 3 separate parts. It's pretty obvious though. And just for reference, I normally draw this vertically because I have a portrait style piece of paper, of course. But here you can see this is in landscape view to fit the screen. So I'm going to be writing this horizontally to save room here. Okay, and that is the HARD. First I start with H and A and I put those close to each other because that signifies heat and AC, and we're going to pick the bigger one. That's why I put them closer together. And then we have RD, which is hard, HARD. But like I was saying, it's really 3 sections because you're picking the bigger of heat or AC. So let's say the AC is bigger and the heat is not. We're going to pick the AC, we're going to disregard the heat, and now we're going to have AC. And for the standard method, we're not going to have demand factors for our heat and AC, so you don't have to worry about that. We're going to take our number, and that's going to be our number we use in the load calculation. But just like everything else, and like how I already explained, we need to make sure that we multiplied by 2 units to get that answer there. Of course, I'm going to be showing that in the next section of actually answering the question, which I guess I will also write that here as well. I already explained it pretty in depth, but normally I will in each section have times 2 written like I was explaining. So I'm going to do that right now to show you a kind of summary of how it should look without any actual numbers. And it's going to be a little easier to identify certain things. And then when we have all the numbers, you're going to be able to check off certain things like the times 2 in every single section. We're going to then get into our ranges, which we do have demand factors. We're going to look at table 220.55 and we're going to use that table accordingly. Of course, you find out the kilowatt rating of your appliance and then how many of those appliances that you have with the same kilowatt rating. if they are rated differently, then they're going to be individual ratings. So of course you're only using the number of appliances section when you have multiple appliances that have the same exact rating. Again, like most stuff that I'm going to explain in this video, my residential load calculation video number 1 really goes in depth explaining all this stuff, and there's actually separate examples of the ranges to where you'll see how to use this table. So we need to know that with ranges, we have the demand factors, but we need to keep in mind that we have 2 units. So you're going to be multiplying by 2, and then of course you also have your demand factors. Okay, and it's not too complicated. It all makes logical sense, and we're going to see when I fill in the question. Next, we're going to move on to dryers, which according to Article 220.54, they are at a 5,000 watt minimum, or the nameplate rating, whichever one is greater. So I'll put 5 kilowatt min. We don't have demand factors for duplexes, because if we go into table 220.54, we see that 1 through 4 dryers is at a 100% demand factor. In other words, we rate them at 100%. There is no demand factor. Okay, but we cannot forget, we got to multiply it by 2. We got to multiply each section by 2, except for this last section. And this is where things get really confusing your first few times of doing this. And this is because after multiplying everything by 2 in each section, which logically makes sense because we have 2 units, then we have this last rule, and that is the 25% of the largest motor. We're only going to do this one time, even though we have 2 units. Okay, so you see I multiply everything by 2, pretty obvious, we're multiplying every section by 2. We get 25% of the largest motor. We're not multiplying that by 2, we're only doing that one time. This accounts for the standard method, we only do it one time, and also duplex, we only do it one time, and multifamily. So all dwellings using the standard method, we only do 25% of the largest motor one time, because we only do this for the standard method. The optional method does not include 25% of the largest motor. Okay, so let's go over that from the top. We get square footage of the house, and we multiply that by 3 volt amps. We get a number. We're going to add 4,500 volt amps to that. This comes from the 2 small appliance branch circuits and 1 laundry circuit. Of course, we have 2 units, so we're going to multiply this total number by 2. I'm going to write this in parentheses times 2 to not mix this up with anything else that might be times 2 in the calculation at any point. Now I can quickly look at this and see that I multiplied this portion times 2, and that will give me that number to the right of times 2. Then we see we have the demand factors, which I'm going to go over in the example. Pretty straightforward if you've already done this before, because you will know how to do it. The next section, we get into appliances. We go into Article 220.53, which tells us 4 or more appliances are rated at 75% if they're 500 watts or a quarter horsepower or greater. This means if these appliances are less than 500 watts or a quarter horsepower, we have no demand factor, and we're actually going to add those at 100%. But what we cannot forget is everything is going to be multiplied by 2. So again, I like to do everything in its own section and do the times 2 one time. I'm going to get into an example, but you'll see I normally separate the appliances that are 500 watts or a quarter horsepower or greater, and I get a number for that because I'm going to be rating that at 75%. And then I take any other appliances that might be less than 500 watts or a quarter horsepower, and I separate those because those are going to be at 100%, and then I add those 2 together. Of course, we're not forgetting that we're multiplying each section by 2. It'll make a lot more sense when I actually get into this. Okay, and then we're going to get into the HARD section, where we start with the heat and the AC. We're going to pick the bigger one. We don't have demand factors for this portion, but we do need to make sure we're multiplying by 2 for the number of units we're working with. Then we get into ranges, and we need to make sure we also multiply the kilowatt rating by 2, because that's what we're working with. Then we need to find demand factors according to the kilowatt rating that we have per each unit and apply that. Of course, it's going to make more sense when I get into that. Then we get into dryers. We have a 5 kilowatt minimum, and we're going to multiply by 2 because we have duplex. Next, we get into the 25% of the largest motor section, and we really need to remember we're only doing this one time because we're doing everything else times 2. We have 2 units, but it doesn't matter for this section. We're only doing this one time. Okay, and now we're going to get into the actual question. Find the minimum overcurrent protection device for a duplex dwelling unit supplied by a single feeder with the following loads on each side. The units are 1,600 square feet. They have a 15 kilowatt heating system, 2 air conditioning units at 40 amps and 240 volts, an 8 kilowatt range, a 4 kilowatt dryer, a 4 kilowatt hot water tank, a 1 kilowatt dishwasher, a 1 kilowatt disposal, a 1.2 kilowatt compactor, a 450 watt attic fan, and a 6 horsepower motor. We start off with 1,600 square feet. I'm going to show you how I'm actually going to fill this in. I know I'm going to have to do all the demand factors and adding stuff, so I'm just going to make a section for myself that big so I have enough room to do all of the math. And then my next section is appliances, so I'm just going to write the appliances in order with the question. And then I'm going to then write the kilowatt rating in order as well. And also, I'm going to pay attention that if there's anything that is under 500 watts or under a quarter horsepower, then I'm actually going to have that after my first appliances. I'm going to separate those from my other appliances, so there'll be a gap between them. I'll just show you as I go. Okay, so looking at the question, can see that my fan and my grinder are going to be that separate section. Everything else is 500 watts, a quarter horsepower or greater. That's my hot water tank, dishwasher, dispo, and compactor. And we have the ratings of 4 kilowatts, 1 kilowatt, 1 kilowatt, and 1.2 kilowatts. And then this is what I actually probably would do on the question, is draw a little squiggly line, because it's not a legitimate dark line, but I still see there's a separation. And this is where I'm going to separate that attic fan. I'm just going to call it fan. And then the motor, whatever purpose it has, I'm just going to call it MTR. That's my motor. If they mention it's a grinder motor or something, you might want to put grinder. Personally, I'm just going to put motor. Okay, and that's at 450 watts for the fan and a 6 horsepower for that motor. And I gave myself a little more room because I know for the motor, I'm going to have to figure out the amps and then multiply it by the volts. And this comes into the question of, okay, well, how many volts is this motor? They didn't tell me anything. They just told me a motor at a 6 horsepower. Well, if they don't tell you anything and you're working with a dwelling unit, then you're going to know that you're working with single phase and you're going to have a 120 volt motor, okay? Because they would mention if it was 240 volts. Like I said, we're going to have to figure out the amps by looking in the book. When we get to this section, we're going to multiply that by our volts and we're going to get our volt amps, which will then be the rating of this motor in watts or volt amps. Here in load calculations, it's good to know that watts and volt amps are the same exact thing. We're not thinking about power factor or anything. We're just thinking about a basic overall calculation. You might consider it almost an estimate a bit of how much power we're going to need for this unit. Of course, there's some variables and some things that might occur that might make one house a little bit different from the other house, but we're just doing a general calculation depending on the square footage and the appliances that we have and the things in the house that are going to take electricity that are therefore going to tell us our total demanded load. Then I'm going to separate everything with a line, of course. Yeah, we're going to move on to the HARD section. I might write this a little differently than I'm normally going to do it on a sheet of paper, but who knows, maybe you'll learn from this and have your paper landscape view and you'll fill it out this way, but you'll get the gist of what I'm doing. So I'm going to start off with heating and AC. The heat was a 15 kilowatt heating system, and of course I know I do this for every section, but just right off the bat, I'm going to write times 2, because simply for this, I'm just going to be getting the nameplate rating and multiplying it by 2. Okay, the AC is a little different because we had 2 AC units. I'm just going to show you how I would fill this in. And that is, I would do the 40 amps, and then I would multiply that by my volts, where we had 240 volts. We're going to get that total number, and since we had 2 air conditioning units, then we're going to need to take that total number and multiply it by 2. Pay attention that I'm not putting the times 2 in parentheses, so when I look back at this when there's a lot more stuff going on, I can quickly see the fact that I did times 2 here. I'm going to get another number, and then I'm going to have to times that by 2 for the amount of units that I have to actually get the demanded load for my air conditioning unit for the duplex. Okay, so we can glance at this and we can see that we multiplied 2 twice. Of course, I'm not just going to have a number there, So I'm actually going to solve that. I just want to get that in your head so it doesn't overcomplicate you. So now I'm going to get into the range, and that is at 8 kilowatts. And then we have the dryer, which the nameplate is 4 kilowatts. And I'm going to get into every section on its own. Before I do that, somewhere at the top of my paper, I'm going to write ×2 in parentheses, and then I'm going to put an exclamation point, and I'm going to somehow make that pretty clear to myself. So when I look back at this in the end and I'm double checking everything, I can remind myself that, okay, ×2, I have to multiply everything by 2. And if for some reason I forgot to do that, well, then I make sure that I didn't miss that in any section, or worse, I didn't completely forget to do that overall. Then I'm going to create my last section here because we have 25% of the largest motor. Of course, this is the only section that we're not multiplying by 2, even though we have 2 units. Okay, so now I'm going to get into the general lighting load section. I'm going to go each section in order, which makes it pretty easy. We have 1,600 square feet. We're going to multiply our square feet by 3 volt amps. We're going to get 4,800, and then we're going to add that 4,500 for the 2 small appliance branch circuits and the 1 laundry circuit. We're going to get 9,300. Of course, I'm doing this all on my calculator. I normally like to do this all in one stream. So I'm going to figure out everything one time on my calculator. And then after that, I'm going to do it a second time just to make sure I get the same answer. Then I'm going to move on to my next section. I'm going to take that 9,300, and of course I need to multiply that by 2 because we have 2 units. That's going to give me the number 18,600. We're going to look at table 220.42 lighting load demand factors, and we're going to see that for dwelling units, we have the first 3,000 at 100%. Then from 3,001 to 120,000 is at 35%. And then the remainder over 120,000 is at 25%. Of course, 18,600, we have nothing that's over 120,000 here. So what we're going to do is we're going to remove 3,000. You can think about this like we're putting it off to the side. Because over here on the side, I'm going to rewrite that 3,000, and I'm going to label that it's at 100%. Subtracting 3,000 gets me 15,600. And from here, I'm going to need to multiply this by 35%, or 0.35. Okay, that's going to give us 5,460. And now we have our 5,460 from getting this at 35%, and we have our 3,000 from getting this at 100%. Now we're going to add those two together, and we're going to get 8,460 watts or volt amps. You can call it either one. And that's going to be our general lighting load portion of this question. Again, I'm going to circle my total number and the GLL so I can just look at this section and I can see the number that I need to add to get that total demanded load. Now, I'm going to spare you from having to watch this, but I would normally do this all over again a second time to make sure I come up with the same exact answer. And I do that for each section. If it's a big section, I might do that somewhere halfway along the way, and then do that again at the end. Okay, moving on to the next section, we have our appliances. Again, I separated it with a squiggly line showing me that I have my appliances that are 500 watts, a quarter horsepower or greater in this section, and this section is the ones that are less than that, as we see with the ratings that we have. So I'm going to start off with the larger section. I always like to label how many appliances I have, and then also the units if we're working with more than one unit. We have 4 appliances here. So I'm going to write 4, but then we don't stop there. We also have 2 units. I always identify 2 units as the parenthesis times 2, so that's just how I do it. And then I'm going to come up with 8 total appliances here. So I'm just going to tell myself here, okay, I have 8 appliances. Right off the bat, I already know I'm going to have that 75% demand factor. Now that I already identified that, I'm going to get into adding this all together. Because I'm kind of running out of some room, just kind of give myself room right here. This is all pretty simple. We're just going to add 4 plus 1 plus 1 plus 1.2. Might seem ridiculous to use a calculator for it, but it's easy to get a little too cocky and then to make a simple mistake and then to not get the right answer. Okay, I'm going to get 7.2 kilowatts. Okay, but we have everything times 2 because we have 2 units. So we don't just have this many appliances. We have all these appliances in 2 different units. So we're going to have to take that total number and we're going to have to multiply it by 2. Okay, and we're going to get 14.4. Again, with this section, we're multiplying everything by 75%. So then from here, we need to multiply it by 0.75, and we're going to end up with 10.8 kilowatts. I just kept everything in the kilowatt. Of course, you could look at this and you could easily tell yourself that this is 10,800 watts. Okay, and always label that it's kilowatt, because then you know it's actually finished. It's not amps, it's not horsepower. You need to label every single thing so you are not going to second guess yourself. Now that this is the total number for this section, I'm going to draw a little squiggly circle around it to tell me it's not the actual final answer for this section, but it's a part of the final answer. Okay, so now that I have that part of it, I need to go into appliances that are less than 500 watts and a quarter horsepower. The fan's pretty straightforward. We have a nameplate rating, but for the motor, we have a 6th horsepower. We didn't get told anything else, so we know that we're going to be working with 120 volts. And we also know we're working with single phase because we're working with a dwelling, and they didn't tell us any other information. We're going to go to table 430.248, which is the FLC or full load current in amps for single phase motors that are alternating current. You got to make sure it's AC. We're using AC in homes here. We're not using DC. Funny fact is that homes actually used to be DC when electricity was invented, and that's the reason why we have 120 volt systems to this day. We wanted to find a number of volts that was efficient for creating wires that didn't need to be too big, and then could also give us electricity throughout our house. Once we start switching into alternating current, electricity could move much further distances, and we could use that potential to our advantage. So the 120 volts stems from the era where everything used to be DC. Can we see for a 6 horsepower motor at 115 volts, we're going to have 4.4. Now you might ask yourself, what the heck? We have 115 volts, then why don't we do 115 volts here? And how do we know it's 120 volts? And that's where you really need to read your code book. If you go to article 220.5, where it says calculations, you see section A voltages. It tells you that you're using nominal voltages. That's here in the load calculations. So when you're calculating all your numbers, when you're doing all your math, you can see the voltages you're going to be using. I already explained this in that first residential load calculation video. It's quite a mouthful, so just make sure you're aware of that. As you see, we have 120 volts, 240 volts, we can also use 208, 347, 480, and 600. We're not using anything else. So here in table 430.248, we see we have some different numbers. 115 volts, 200 volts. Well, we're going to have to make sense of this and correspond this to our nominal voltages when we're doing our load calculations. So we're going to get 528. I'm running out of some room, so I'm just going to draw that here. We have 528 watts from 120 times 4.4. Okay, since we now have our load for the motor, we're going to add the fan and the motor load together. Of course, we see 450 watts plus 528 watts. That gives us 978, and then remember, we have 2 units. We're multiplying everything by 2. So we got to multiply that by 2. Of course, this doesn't have any demand factors. So after we multiply it by 2, we have our total answer for this section, and that is 1,956. Now again, I might do a little squiggly circle here to tell me this is the other part of this section. Now I'm going to add my 1,956 to that 10,800 that I got in my other section of my appliances that were over the 500 watts and quarter horsepower. All right, 1,956 plus 10,800, and that gives me 12,756 watts, and that is the total number for my appliances. So I'll just put APP appliances. I'll give that a nice circle that I could easily see and distinguish in the section. I don't have a lot of room, but I'm making use of the room that I have, and I'm making it pretty obvious of the answers that I got in each section with the squiggly circle. And then I can also see the big circle with the final answer. Again, like I explained, I would normally do each section again separately, figure out the separate answer. I would have already done that 2 times by now. I do everything twice to double check. And then after I get that final answer, I would then just add that again twice just to make sure I get that final answer again. Make sure everything's consistent. But I'm not going to do everything twice here for you on video. So make sure you do that. And now we're moving on from the appliance section. Before I move on, I can glance and see that, okay, I did do the first section times 2, and then I also did it at the 75%, and then I also had my second section times 2. So it looks like I did everything correctly. Now I can confidently move on to the next section where I have my heating, 15 kilowatts, and then I have my 2 units. And then I also have my air conditioning where I have 40 amps and 240 volts. And then I'm going to put that in parentheses because I have 2 actual air conditioning units. Okay, and then from there I have an additional times 2 for how many actual dwellings I have. And I'm just going to keep that all in mind and also label it with the fact that this times 2 is not in parentheses. I'm going to pay attention and remind myself of that, so I know that I still have to do times 2 for the amount of dwelling units. Of course, we could start with heat, top to bottom, and we get 15 kilowatts times 2. Of course, that's pretty straightforward. We have 30 kilowatts there for the heating. Now let's check the AC. So we're going to get our volt amps. We're going to do our amps times our volts. 40 times 240 gets us 9,600. And remember, we're multiplying that by 2 because we have 2 air conditioning units. This is where you really need to keep your mind sharp and really be on your toes and think about everything that you're doing and everything you need to do. We're going to get 19,200 watts. And then we're going to now multiply that by 2 in the parentheses for the 2 dwelling units. That's going to give us a total number of 38,400. Okay, so if we compare 30,000, in other words, 30 kilowatts, to 38,400 watts, then we can see obviously we're going to be choosing the air conditioning. We can also see that if we forgot to do one of those times 2, we would have picked the heating at the wrong number. Okay, so we have 38,400. Make sure you have all this written down if you don't, because I'm going to have to erase a little bit to make some room for the other section. Okay, so in all, we can sum up this section as we have 38,400 watts, and because of that, we're going to be picking that and not the heat at 30,000 watts. I'm also going to label this AC. So again, I can look at this section. I can see this is AC. Normally I would have not erased everything, so again, you'd be able to look back at this and double check. You have the times 2 for the amount of air conditioning units, and then you also have the times 2 for the amount of dwelling units. Okay, moving on to the next section, we're going to look at range, and we see we have an 8 kilowatt nameplate rating. Make sure to pay attention to that kilowatt rating because that's the actual rating of your appliance. Of course, we're going to have 2 of these, so we need to keep in mind the 2 dwelling units. So we're going to end up with 16 kilowatts in total for that rating before we do these demand factors. But in order to find out what demand factor we're going to be using, we need to remember the rating of the individual appliance. It might seem a little confusing at first, but it logically makes sense that when you want to find out the derating factor, in other words, what they call demand factors, you're going to want to know the actual rating of your individual unit, and then the amount of appliances that you have. That's going to tell you a percentage. You're going to take that percentage and you're going to multiply that percentage by that total kilowatt number when you add your actual appliances together. So it sounds like kind of a mouthful, but it's a little complicated, but it makes perfect sense when you do it a few times. It's like a lot of things, it's a lot more complicated to actually explain it into words than to actually do it. So if you just do this a few times, then you will remember how to do it, and there's no need to comprehend it any further than actually being able to figure it out, unless you sit back and you tell yourself, okay, how do I actually do this? Okay, so let's actually do it and we'll see what I'm talking about. We see that the actual rating of the unit is 8 kilowatts. We're going to go into table 220.55, and we're going to see column B is 3.5 kilowatts through 8 3/4 kilowatts. Because of this, we're going to be using column B, because that is corresponding with the rating of our single appliance. Then we go over to the left, we see number of appliances. We're working with 2 appliances here because we have 2 units. We see that in column B, at 2 appliances, it lines up with 65. This is telling us a percentage because above it you see these 2 sections, column A and column B, have demand factor percentage above it. Okay, so column A and column B are percentages. We have 65%, so now we know that we're going to multiply our total number by 65%. Our total number is simply the rating of the appliance and how many appliances that we have. We have an 8 kilowatt rating of the appliance, and we have 2 of them. 8 times 2, we have 16 kilowatts. and we're going to multiply that by 65%, 0.65. That's going to get us 10.4 kilowatts, and that is for the range, so I'll just draw an R in a circle. And then for the dryer, we have that 5 kilowatt minimum. So we have a 4 kilowatt nameplate rating. Well, we need to make it 5 kilowatts minimum. And we also have 2 units, so we're simply going to take our 5 kilowatts, we're going to multiply it by 2 for our 2 dwelling units, and we get 10 kilowatts for our dryer section. Okay, the next section is the 25% of the largest motor. Like I explained in my part 2 of the residential load calculation video, you're finding which of your appliances has your largest motor, but you're not figuring out which of your appliances with the largest rating contains a motor. You're finding out what is your largest motor in these appliances. Okay, and this is really important because let's say we had a dishwasher that was 2 kilowatts, and we had the compactor here at 1.2 kilowatts. Well, dishwasher contains some motors. You have the things that spray the water on the inside spinning, and maybe some other things happening that will include a motor. The dishwasher only has little motors, and the motor is not the main function of the actual appliance. If you take a compactor, for example, that's going to have a much larger motor that's actually going to serve as the main purpose. So because of that, we're going to pick our appliance that has a big motor in it, the largest motor. We're not just going to pick any appliance that contains motors, but they have a motor that is actually used as the main function of that appliance. This is where they might get you. Okay, so obviously we have the compactor. That's at 1.2 kilowatts. Getting 25% of 1200, we get 300 watts. Now we have all of our separate numbers for each section. We can easily see the number that correlates with each section, and we can also easily see the final numbers that correlate with each section. It's very clear to see. You want to make sure that you do this when you're filling it out too. And now, because I need to make up some more room, I'm going to need to erase some stuff. So make sure you have this screenshotted, written down, or maybe even in a new tab. I'm now going to erase some stuff, and then we're going to add everything together. Okay, now before you add everything together, just double check that you filled in each section. You see the general lighting load section has its number. The appliances have its number. We have to pick the bigger of the heater, AC. We see AC with a number. We see the range and the dryer each have a number, and then the 25% of the largest motor also has its number. Now, if you've done this enough times, you know that's everything you got to do. Now we can add everything together. We're going to get 8,460 plus 12,756 plus 38,400 plus 10,400 plus 10,000 plus 300. We have a total number of 80,316. You want to write this down, and then you want to add everything again a second time to make sure you come up with that same answer. Okay, so I'll add everything again, and I get 80,316. So I see that, yes, I got the correct answer. I also double checked every other section along the way, so there's a very good chance here that I did not do anything incorrectly. And I know I didn't here, but it's the train of thought that you got to have, that if you double checked a bunch of things along the way, then you already know you did everything correctly now. You don't have to panic at any point and say, did I do a certain section correctly? Did I not? Okay, so you're going to form that confidence. And I like to box my final answers. So here, because this is the actual final wattage, in other words, the demanded load of this duplex, then I'm going to have my square, so then I can look at this, see this is a final answer. But I also need to know that if I want to find my amps now, then I'm going to have to take that and divide it by 240 volts. Of course, because we're working with volt amps here, watts, we're going to divide by volts, and we're going to get our amps. You are working with residential, but because we have the two-phase system A and B, we do have a 240 volt potential, and that is what we're using to divide by to find our amps. We get 334.65. Okay, now it's good to know you're not going to be rounding a bunch of things up until you get to amps. Again, this is why it's good to read stuff. We go back to article 220.5 calculations, and we see section B. It says we're going to round to the nearest whole ampere with decimal fractions that are smaller than 0.5 dropped. So just like how we already know how to round numbers up, if it's 0.5, we round up. If it's less than that, we're going to round down. So we see we have a 0.65. It's obviously more than 0.5. So with our amps, we're going to round up to 334.65. 335 amps according to the code book. Okay, and I'm going to do a squiggly circle here because I know personally that that is not a standard size breaker. Regardless, we're going to go into table 240.6a, and we see that's where we get our standard ampere ratings for our circuit breakers. We had 335 amps. Okay, so we see 300 amps and we see 350 amps here. We're going to round up to 350 amps, but we need to know the reason why we're doing this. Okay, the reason why we're doing this, because if you think about it, the breaker is telling us how many amps we can put on our wire. And if we just figured out our total demanded load for our duplex, and this is our total amount of amps, then why would it make sense to size up the breaker telling us to put more power? You might say, well, logically, we'll round up so you have more power. It makes sense. And that could make sense, but you could give an argument for both sides. And that's why it's good to actually know what the code book is telling us to do. And that's why we got to go back to Article 240.4, Section B, and we see that overcurrent devices that are rated 800 amperes or less, we're going to be choosing the next higher size of that overcurrent device rating. So what this means is that if you're in the middle of two numbers here in table 240.6a, you're going to round up to the next biggest number as long as that next biggest number is not over 800 amps. Funny enough, a lot of practice questions don't even do this, and they do this part of the question incorrectly, but that's why it's good to know what the actual code book is telling us. The people writing the test are going to know the code a lot more than people writing the practice tests who are helping, but they're also making money off it. And no offense to people creating these practice tests, but I find quite a lot of mistakes in every single practice test that I get, which shows me that these people who are making these practice tests are not really double checking everything completely thoroughly. And with that, it gives me the feeling that they're just trying to make money off selling these practice tests. So if you're frustrated doing a practice test and you can't figure out why the answer isn't correct, there's a chance that the person actually made a mistake and you're trying to learn from them. This is part of the reason why I made this YouTube channel, is because there's a lot of confusion in this whole topic of trying to figure out these electrical questions, and there's a lot of misinformation out there as well, along with people not knowing how to do things correctly or leaving out a few crucial steps, which then will make your answer incorrect. Okay, so that's why I explain everything so thoroughly in these videos, is because I've never had anyone explain any of this stuff thoroughly to me, and I hope that anyone that's watching this will get a lot of use out of this. Okay, so that's why I'm happy to be able to share this information with you, but I'm not going to be able to do this for much longer if I don't have any money coming in for this. So if you do want me to keep doing this and you want to support me, just leave a comment below and let me know that, hey, you'd support me doing this, and then I'll post some more videos. But realistically, I'm going to have to reach the end of this pretty soon because I need to make some money. So if you want to support me, I'll be more than happy hearing that. Okay, so we have our number for our overcurrent protection device. In other words, the question was asking the minimum overcurrent protection device. After solving all this stuff, rounding up, sizing up the next circuit breaker, now we know that overcurrent protection device. If you don't know what that means, overcurrent protection device is just basically any breaker. So this is going to be our main breaker, 350 amps. Or in other words, our service. Okay, so now that we know we have a 350 amp service, what size wires are we going to use for this? Well, for this, we're going to go to table 310.12, and we're going to see that a service or feeder that has a 350 amp rating is going to use 350 kc mil copper and 500 kc mil aluminum. Okay, so I'm just going to label that. Okay, so the question didn't ask that, but now we know the size wire that corresponds with our service, whether we're going to be using copper or aluminum. And if you're doing a test question, they're probably not going to ask you the wire size, but in real life, you're going to need to know your wire size. So it's really good to know. And there's really not much more else to do here. So this is the end of the video. If you got something out of this and you enjoyed this, give it a thumbs up. Share this on social media with friends or people that you know will enjoy this. And make sure to subscribe to see more of my videos that are going to be coming out. Until next time, take care and goodbye.